All right, good morning, good afternoon, good evening, depending on where you're joining us today. And welcome to the session from InfoWorks. We're going to talk about how you can start making the most of your talent and time by using automation to take care of your data grunt work. So I'm Ramesh Menon, head of product management at InfoWorks. Over the last 20 plus years, I've worked on solving various data challenges ranging from identity resolution, master data management, and very large graph traversals. And now at InfoWorks, I'm focused on automating data operations and orchestration. Kevin?
Yeah, hi, Kevin Holder here. I run our field engineering team here at InfoWorks. And my background is I've got about 20 plus years also in enterprise data warehousing, analytics, big data, and NoSQL space. And I've worked with a lot of large enterprises to help them, develop, implement analytics infrastructure during my career.
Great. So between the two of us, we have about 40 plus years of experience with data.
That's a long time, Ramesh.
So what we're going to do over the next 30 minutes is have an interactive dialogue about data challenges and how to overcome them. So Kevin, you've helped a lot of enterprises with their data strategy and data management. Can you describe the different tasks that data engineers and data scientists typically have to do?
Yeah, Ramesh, I'd love to talk about that. And, some of the challenges really can be summed up with two words: grunt work, right? So, but the diagram here really shows the hierarchy of what data engineers, data scientists are generally working towards, and really the cool, the fun stuff is at the top level of the pyramid, and that's really where we want to be spending our time, is on the machine learning, training models, doing the advanced algorithms, but in reality, we end up spending a lot of time on these lower tiers, right? Um, collecting data, get it ingested, preparing it, aggregating it, and doing those types of things, right? And it's an environment where more and more use cases, keep coming at us, shorter time frames to deliver, less folks on the data teams to chip in here, and so it really becomes a challenge. And I'd love for you to share, some of your thoughts on, based on your experience, kind of why that is, because, we've seen the same type of pattern even before big data in the cloud, back in the early days of data warehousing. It was the same thing, people spending, about 80% of their time doing this back end work as opposed to the higher value added stuff. And quite frankly, this is the boring stuff, and we want to be able to free up our time and do the cool stuff, the fun stuff. So why is this pattern, continuing, Ramesh?
Yeah, that's absolutely right, Kevin. So for decades, ETL has been the way to get data ready for analytics. These ETL tools were designed to replace scripting, typically with a visual programming paradigm. And the flow usually was grab a table, do some transition on it on the way, and land it somewhere, typically in a data warehouse. Now, with big data, cloud, and the sheer scale of modern analytics, we need to do a lot more. New challenges have appeared, like you can see in this slide, and have massively increased the grunt work needed for getting data ready for analytics. And at the same time, the requirements and the volume of new analytics just keeps increasing.
Yeah, it's a great point, Ramesh. And if you look at the things on the list here, you mentioned ETL tools. ETL really don't address, in an automated way at least, these types of things here that are really relevant for the big data world, the cloud world that we're in now, right? The tools were great for the data warehousing paradigm, or you could pick up a table, move it from point A to point B. But to do these types of things that you have on the screen here is really challenging, right? Because you end up developing a lot of different maps and scripts, and you're working at too low level of a paradigm. And I don't know about you, but I've never been able to kind of map and script my way out of some of these challenges using traditional tools. And we're actually seeing a lot of people really start to hand code these things, moving away from those tools, right? Which just, so how do we, I know when you were building the ideas around InfoWorks for the product, you really had an opportunity to rethink the space that you and I had worked in for so long. And so how did you go about rethinking that? And what is unique about what we're doing here to help solve these specific challenges?
Yeah, that's right. I mean, I'd add that mapping and scripting, rinse and repeat, didn't work too well, even in the sort of the ETL and the data warehousing days.
That's true.
So, we started with looking afresh at the problems and the solutions, right? And the answer is pretty clear. It's that whenever there's complexity, automation solves it. Automation makes dealing with the grunt work easier and faster. It helps one to do work faster so that we can focus on those higher level problems that we need to solve, like you pointed out, earlier on. So we created Data Foundry to be a deeply automated system and to provide the complete functionality for creating and deploying data workflows. So what's in a data workflow? You start with onboarding your data. That's getting it from these source systems into your data lake. Then you prepare your data, get it ready for analytics, and finally operationalize it. So next, we will walk through each of these steps that can be automated across your entire data workflow.
Yeah, and while we're walking through these, we are going to put this within the context of a demo, and we'll show a complete end-to-end use case, going all the way from data sources to training a machine learning model in Databricks using a notebook, and really show how you can simplify that notebook, focus in on the value-added development that you want to do there, and leverage InfoWorks to help automate some of this back-end work to help you really focus your talent and time on more important things.
Yeah, so let's get started with the first step, which is onboarding data. There are numerous challenges that need to be solved here. And as any one of us who've actually had to deal with getting data over into these data lakes and get them ready for analytics know that there are things starting with discovering the data that's available in the sources, understanding what the data types are, mapping them, and converting them properly so that you don't lose data precision. It's about change data capture. It's about making sure that incremental works really well. It's about not only data change, but schema change and schema drifts. All of these things need to be taken care of because data onboarding is this really critical and the complex first step in your analytics process. These issues that you can see on the left-hand side here are really complex and time-consuming, just examples of those kinds of data grunt work that we're talking about. So I'll hand it over to Kevin so that we can see how automation can take the grunt work out of onboarding data.
Okay, thanks, Ramesh. So when I log into InfoWorks and start using the system, one of the first things that happens is InfoWorks will reach out and automatically crawl the metadata for the sources that I want to ingest into my Databricks Delta Lake environment. Your data sources, and we work with a lot of large enterprises who have sources that range, and you can see on the screen here, CSV files, relational databases, data warehouses. InfoWorks has a lot of different connectors for most of the major different types of data sources that you may have out there. And so we crawl the metadata for those, and we create a catalog automatically. This is 180 degrees different than what traditional tools have done. And then we drive the entire process off of that catalog going forward. And this automatically enables a governance framework that allows you to make sure that you can govern what you're doing over time here. I can go into this data catalog. I can search. So if I search, for example, for consumer, this will return my data set here that I want to work with. And then I can click in here and I can see the details behind this. So in this example, we have 3 different tables that are part of this consumer loan data set. 2 of these have been ingested into our Delta Lake environment already. And I can tell that one of these is an incremental ingestion. One of these is a full refresh every time it runs. I can tell how many records have been there, what the status is, et cetera. I can also tell that this one has not been ingested yet. So there's some additional configuration that needs to be done. I can also click on and get to table details for any of the objects that are here in this catalog. This case, I have the schema here where I can scroll through. But what I really wanted to highlight as it relates to automation is this automated process that we apply, that Data Foundry applies to every single table that's ingested into your data lake. This process flow here will handle automatically creating a changes feed, a error handling table automatically where errors can be routed. There's a continuous merge that's automatically there to help keep your current target in sync with your source. And then there's a history option that's available, and this can be turned on and off based on the particular table and what your needs are. But this, if you turn this on, this will automatically start to track history at the row level for data that's being ingested into your Delta Lake environment. With traditional tools, this will require a lot of drag and drop mappings, or mapping and scripting we were talking about earlier to accomplish, which is error prone and not consistent, right? This is automated completely for every single table that you ingest into your data lake environment.
Great. So Kevin, now we have all the source systems crawled, ready for bulk ingestion. We're keeping it synchronized, and everything's in the catalog. So as you said, there's no need to map and script your way out of it, and everything leverages automation, and it's completely configuration driven.
That's right. And one of the more common questions that I get at this stage of showing the product is, hey, this is great, but I've worked with higher level tools in the past and I run into limitations, right? One of the really powerful things about InfoWorks is that we're giving you this level of abstraction to work in and get things done very quickly, but we also allow you to get in and configure and tune the process at a very low level to give you the power that you're looking for. And I can easily do that. If I click on configure, this will take me into the configuration panel for this particular type of source that I'm ingesting here. I can choose options such as full refresh, or let me make it an incremental. I can specify natural keys so that we can automatically understand how to identify unique records. I can choose my incremental mode, whether it's append or merge, choose watermark columns, create my schema information for the Delta Lake side of things. I can even get into easily configuring how I want to partition the data within the data lake. I also talked earlier about the history. With this checkbox right here, I can click that on and get a quick enabled history, SCD type 2 for data that's being ingested into the data lake. So there's also an advanced configuration tab that allows you to go in and do even deeper configurations. That's the onboarding process. So Ramesh, why don't you take us into the next phase of our journey here?
Absolutely. So once we've got data onboarded, the next step is really preparing those data sets to be ready for analytics. Now here too, there's a bunch of complex things that need to be done. So typically, what I would need to do is combine these data sets. But before that, I need to standardize them so that they are in a common format or they are joinable. I'll have to deal with data quality issues and typically have to do some sort of data cleansing. Then I also need to worry about data lineage. So for example, if I derive a new column, I need to keep track of where this column was derived from, what data sets, which sources it came from, and also looking downstream if there are folks who are going to be using my data model as input into their own data workflows. I need to be able to understand the impact of anything that I might do when I go to change those data models. My analytics use case might need record versioning. So as Kevin just mentioned, SCD2, I might need to maintain SCD2 in my data model targets. Even when I'm done with developing all of this business logic and implementing these data transformation pipelines, I also need to think about performance optimization. Do I need to use broadcast joins? Do I need to do in-memory sorts? Do I need to do dependency management? And if I'm running in modern cloud infrastructures, how can I leverage on-demand and ephemeral infrastructure? So these are all additional complexities that make really a lot of grunt work show up in the prepare data step. So Kevin, I'll turn it back to you so that you can show us how automation can help with this stage.
Sure, thanks, Ramesh. So let me go over to our data pipeline editor. In the previous demo, we were able to ingest data and keep our data lake synchronized with our source. And so we have a raw set of data that maps directly to the source structures, and we may have hundreds and thousands of tables coming in here. That is very useful for a lot of use cases. However, for a lot of use cases, we also need to take data from multiple sources and combine those together and apply business rules and create new data models within the data lake. And that's what the pipeline designer allows us to do here. When I go into a pipeline, I can see different versions that might be available. So InfoWorks has out-of-the-box version control built in. This is telling me that I have 3 versions of this pipeline available here. This one is my active version. So there's an older one out here, and then it looks like there's a newer version out here that someone is working on to promote into production later on. If I double click on the pipeline, this takes me into the editor. And when I'm in the editor, I can get to any of the data sources that are available to me within the domain where this pipeline lives. I can also access data that is being created from other pipelines. So I can chain pipelines together to handle more complex use cases. I also have the palette down here, which has a lot of different transformation options available. Everything from filters to joins to fuzzy matching to various different targets for cloud-based data warehouses where I may want to push some curated data sets to, statistical analysis functions. So really the idea here is to drag and drop these things onto the palette and then use the transformation objects to create your business rules. In this example, I'm taking these 2 tables, and for each, I'm going to derive some new columns, do some cleansing on it, join the data together, and then write it out to a target. One specific type of automation that I wanted to highlight here is the ability to do incremental pipelines very easily using a simple checkbox. You saw in the ingestion part of the demo how we can do an incremental ingestion from a source. With that ingestion, we're managing the watermarks and the dates that these records are flowing in, and that allows InfoWorks to know, okay, if I check this box, I can then pick up data and process data incrementally. With traditional tools or platforms, that takes a lot of mapping and scripting that we talked about earlier to do. You end up reinventing the wheel quite a bit. We can do that with a simple checkbox, and you've got your incremental processing enabled. I also wanted to highlight something on the target side as well. If I go into this target, I can specify a lot of details about how I want this data materialized into the data lake. I can pick the type of synchronization I want to do. I can choose if I want to do an SCD type 2. So if we need to track history on this target as well, I can specify that. I can configure it, and that's automatically enabled through this simple drop down here. I can specify my path information and my format for loading this into Delta Lake in a Delta format, specify keys, partitions, all the same type of power that you saw on the ingestion side, we can configure here. And then when we deploy this to production, this job will run, pick up my data sources, apply the business logic, and land a new model into the data lake.
All right. So, Kevin, a lot of enterprises have a lot of legacy SQL workloads, typically, in data warehouses that need to be reused or could be reused. But to convert them into Spark, preserve the logic and do performance optimization is a lot of grunt work again. So, perhaps you can show us how that can be automated.
Yeah, that's a great question. So I went into the configuration panel for a pipeline, and we have the ability to import SQL workloads, and we support a number of different dialects, Hive, Teradata, MySQL, Oracle, SQL Server. You can choose that. You can choose how you want to handle double quotes, backticks, et cetera, inside of the SQL statement. We will import this and create a graphical representation based on how we parse that SQL. So you'll get a graphical pipeline, just like the one that you saw, that was built out on the designer there. The cool thing about it is, I may pull in a Teradata SQL, generate that pipeline, and then once it's in InfoWorks, we can then turn around and deploy that easily into a Spark as a Spark job running in Databricks, for example, right? So real easy way to start to migrate some of your legacy workloads over and deploy those as jobs that are running natively inside of Databricks. So that's a great question. One other thing I want to highlight here is, when we created the target in the pipeline that you saw, that is automatically integrated into the data catalog as well. So I went back to my catalog view here, and I moved from data sources over to data models. And I can see all the different types of models that are now being created as output from the pipelines that are being run in this environment. So, again, automatically integrating this back into the data catalog, so it's here, it's searchable, and delivering that governance framework that we talked about earlier.
All right. Okay, so now we are at the last stage of the data workflow, which is really the stage about operationalization. There's a lot of grunt work there too that needs to get automated. Now, this is especially challenging because a lot of analytics projects get stalled because of difficulties in moving data workflows into production. Typically, this requires a lot of rework or additional work to handle operational requirements. So as an example, if I have to orchestrate a multitude of lower level tasks that comprise a use case, so a few ingestions, a couple of data transformation pipelines, et cetera, those all need to get stitched together in the right sequence with the opportunities for parallelization and so on. That requires a lot of thought and effort. The other part of it is that infrastructure will have failures. So, networks may go out for a little period of time. There may be, servers or source systems that may have outages. And so how can I make my data workflow fault tolerant? So, resume from the last successful point or restart, pause, etc. And also deal with scheduling. How often should this run? Every hour and so on. And those kinds of things are just a lot of additional work that a lot of times people have to do using low-level tools. Even when I have this deployed into production, I typically need to monitor my performance of this data workflow against an SLA. And once I'm doing that, I also need to be able to balance cost and performance and get access to all the relevant metrics. So once again, lots of grunt work here, and automation can tremendously help with this. And I'll turn it back to Kevin so that we can see how automation can help here too.
Okay, great. Thanks, Ramesh. So let me move over into the workflow section of InfoWorks, where we can design a workflow. What you're seeing here is a palette where I can build a end-to-end workflow to drive the use case that we've been building here. The first steps here are to ingest those two data sources that we configured. I can do that in parallel because there's no dependencies there. So those will run simultaneously. When that completes, then I want to execute a data pipeline. So we'll run the pipeline that we just saw in the last demo. And then assuming the pipeline gets built and all my data is prepared and ready to go, then I'm going to call a node to execute a notebook over in Databricks. And that notebook will contain the advanced algorithms to train the ML model to complete the use case here. These are very easy to configure. I drag the object onto the palette here, and then I can double click into any of these and quickly configure them using a series of drop downs. So this is an ingestion task. I can pick my data source, my tables. For my pipeline, I can choose the pipeline that I want, a specific version that I want to deploy with this workflow. And then in this node, we're actually using some script with some conditional logic and error handling to call a notebook over in Databricks and orchestrate that. And this will be fully integrated into this workflow, including error handling, so that we can literally deploy and execute this entire end-to-end flow inside of InfoWorks. After I build out the workflow, I can then go in and easily put it into production and start to run this on a schedule. It can also be triggered through an API. So if you want to run these on demand, and then we will track a complete history of every time this workflow runs. And so, for example, I can tell that this job failed here. I can go into this and I can quickly tell, okay, these completed successfully. I did something wrong in my code for my notebook that caused it to fail. I need to go fix that, right? After I fix that, I can run the workflow again, and it will pick up from where it left off. And now I can tell that this completed successfully. But the key there is it's not going to go back and re-execute the ingestions and the pipelines again. It will literally pick up from where it left off and continue processing from there. So that's a really powerful capability to help you manage your environment. We also are tracking detailed metadata about these jobs and for each individual run. And you can do a lot of reporting on that. This is a simple Gantt chart view that's showing me for each of those tasks within this workflow exactly how much time each of them took. And it's even showing me the number of Databricks units that were used for this particular task and the number of core hours that were used in the cloud. And this can all be aggregated up, and you can report at the job level, at the task level, roll it all the way up to domains, and have some very powerful functionality there. The last thing I'd like to show is the notebook that we're calling at the end of the process here. This is a Databricks notebook that's going to train a model. This is a simple notebook here. And this is really where, the data scientists and, data engineers really want to spend their time, is doing the advanced work here, right? So traditionally, this notebook was much more complex because it had the logic to ingest the data, do the synchronization, or it was actually multiple notebooks that we were orchestrating in a flow. But it was much more complex, right? We're able to simplify this down by using InfoWorks to handle and automate the ingestion, the data preparation steps, taking care of all of that, and then executing this at the end of that flow, and then doing it in a complete end-to-end workflow. The nice thing about it is, now this can be updated. So if a month from now the business comes back and says, "Hey, we have a new data set, we need to go, retrain the models," we don't have to go through a lot of manual steps to make that happen. We can now feed that data back in through this process, train the models, have it deployed, and everything is updated and ready to go.
So what we really did is go through all of the different data grunt work challenges that occurred every stage of the data workflow. And Kevin, I'm really glad you showed the example of SCD2, because it's something that I've personally struggled with using other tools over the last decade or so. So it's a great example of how automation can really make things simple, and also
Sounds like
that
you have some scar tissue from the mapping and scripting.
That's right. So I'm glad there wasn't any mapping
Okay.
and scripting there. So, so if we summarize, right? I mean, onboarding your data is the first step. It's not only about ingestion; it's about synchronizing. It's about keeping all of this under a data governance framework, preparing your data with data transformations and business logic to create those data models that users will use for analytics, and finally operationalizing it, moving it into production, and making sure that your data workflows are running in a fault-tolerant way. So if you're wondering about how to learn more, Kevin can describe that for you.
Oh, yeah, absolutely. So we have a booth at the summit this week. So we'd love for you to drop by the booth. Come by the booth, hang out. We can take you deeper into the InfoWorks, product. Go, do a deep dive into everything that you saw here. We'd also love for you to get your hands on the product and play around with it. So, go to infoworks.io, and there's a lot of resources there, and you can go there to get your hands on a free trial also.
All right. So, thank you again for your time, and, please provide us your feedback. Don't forget to rate and review the sessions. Thank you again.